Hello everyone! Magandang hapon po sa ating lahat and welcome to the Division Webinar Series on Science Content and Teaching Strategies in the context of most essential learning competencies for Grade 4 Science teachers. At heto na naman po kami ng aking partner. Once again, we are your today's moderator. My name is Bernadette de la Cruz of Paisawan Elementary School, Bagak District.
And I am Mary Jane Espiritu of Gabaldon Elementary School, Limay District. To begin our program, let us broaden our love for our country by singing our national anthem and seek guidance, wisdom, and power from our Almighty through an audiovisual presentation.
Mga kababayan, ang pambansang awit ng Pilipinas.
Kayang magiliw, helas ng sinakalan, alam ng puso, sa dikit mo'y buhay. Lupang hinirang, kuya ka ng magiting, sa manlulupin, di ka pasisikin, sa nagatak tutok sa simoy at sa langit mong pagaw, ay hinatang tulad, awit sa pagkayang minamahal. Ang isang ng matawad mo'y tagumpay na naghihingi, ang bituin at araw niya kailan pang ay di magtitingin. Luman ang araw ng walhagit pagsinta, mo'y langit sa piling mo. Ang inigaya na pagkay mga akin, ang mamatay ng dahil sa'yo.
Give thanks to the Lord for He is good. His steadfast love endures forever. To formally start with this seminar series, let us all hear the welcoming remarks of our inspiring, dedicated, and enthusiastic Education Program Supervisor in Science, Dr. Edwin Riel Bermilio.
Magandang buhay po sa lahat. Welcome to the last wave and leg of our Division Webinar Series on Science Content and Teaching Strategies in the context of the most essential learning competencies for the fourth quarter. Sabi po ni Henry Ford, coming together is a beginning, keeping together is progress, working together is success. And I believe that this highlights the importance of working together in teams for Science Department from first to fourth quarter of its activities. With this, I would like to personally take this opportunity to express our sincerest gratitude for the success of all our science webinar series. To our school's Division Superintendent, Dr. Roland M. Fronda, to our Assistant Schools Division Superintendent, Sir William Roderick R. Falurin, words can neither qualify nor quantify how helpful your guidance and advice has been. We are forever grateful for your support sa Science Department. We continuously learning from your examples, because your leadership is not just about titles or positions, it's about one life influencing another. Thank you po, Sir Roland and Sir William. To our Curriculum Implementation Division Chief, Dr. Milagros M. Peñaflor, thank you for your trust and confidence. Your support and guidance have been instrumental in helping us to provide quality science curriculum instruction by enhancing the content knowledge and pedagogical skills of our science teachers, including alternative learning system from grades 3 to 12. To our public school district supervisors, science department heads and coordinators, and our elementary school principal coordinators, our sincerest thanks for selfless support in all our endeavor. Your dedication, compassion, skill, and professionalism will allow us to get through all the activities with flying colors. And we are all indebted to you. We appreciate your sacrifices to be at work. We want you to know that your actions are seen and appreciated. To our team leader and assistant leaders per grade level who had been working countless hours to make sure that everything is okay. Sabi po ni Mother Teresa, God does not command us to do great things. God commands us to do little things with great love. Not all of us can do great things, but we can do small things with great love. Maraming salamat po sa pagmamahal. Amidst the challenges, I am also very grateful to have our intelligent, strong, competent, and brave resource speakers who took the challenge as learning facilitators. Thank you for great performance, dedication, and expertise in delivering quality instruction to the teachers and learners of the SDO Bataan. Of course, special thanks to the members of the program management team in charge for online platform, program design, Google Forms, and our moderators for the hard work and for silently working behind the scene just to make sure that we have tools and resources available. We value all your dedication to keep us up and running. Your efforts are truly appreciated. To our science teachers, we hope that the trainings we have provided will help contribute improve students' learning outcome, develop strategies and approaches, and encourage quality implementation of science curriculum and implementation. From the first until this fourth quarter webinar series, your individual commitment to a group effort is what makes a science department. Maraming salamat po sa lahat. God bless us all.
Thank you po, Sir Edwin, for that wonderful thought of yours. You are indeed a role model to us, always eager to support and encourage us even during a pandemic. After hearing our EPS message, let us turn our attention to the screen and listen to our CID Chief, Dr. Milagros M. Peñaflor, for her encouraging statement. Good morning po, ma'am.
Today is your last among the 4 webinar series of this kind in science. I am glad that you all were able to make it. Congratulations to everyone, my dear science teachers, department head, principal coordinators, and to Sir Edwin Bermilio for the untiring efforts in bringing a quality science instruction to our young people amidst the challenges. We are now on the 4th quarter. It's like that we are ending the school year, but most of the wrapping up activities will be in this last quarter. The remediation, the catching up activities, plus of course, the readiness of our learners for the year-end assessment. Let us see to it that all competencies reflected in the most essential learning competencies are learned by our students. The provincial government, in line with the development of the Human Index, would like to measure how our schools perform, how our learners fare considering the implementation of the learning continuity plan of our schools. I know that it is really hard to cope up with the many challenges, but I have seen how you did it with so many times with the issues and concerns in science. The challenges lies not only with our learners having the competencies, but how we make them critical and creative thinkers. Today's session hopes to deliver both as our competent speakers dwell on interesting topics, putting premium on the plight of our teachers in teaching the skills, how this could be a ready hand for teaching lifelong learning skills in science. Thank you for everyone's participation in this webinar. Thank you for your resiliency in pushing through up to this last quarter. Thank you for keeping up with your promises para sa bata, para sa bayan. Happy day, happy learning, and God bless us all.
Thank you for that warm and inspiring message of our ever beautiful CID Chief, Dr. Milagros M. Peñaflor. Positive leaders instill hope for success and confidence in their people. They inspire others to achieve their goals. And now, let us all hear the dedicated, knowledgeable, and modest person, our very own OIC Schools Division Superintendent, Dr. Roland M. Fronda. Magandang buhay, sir!
Good day to all the participants in the webinar series on science content and teaching strategies in the context of essential learning activities for the fourth quarter for grades 3 to 12 in SPO Bataan. We are nearly 1 month to go for the closing of school year 2021, and we have hurdled, we have surpassed, we are survivors. These events likewise culminate the webinar which the division has initiated from the first quarter up to the last quarter. And I am certain that what we have experienced from the time we started this uncertain and ambiguous journey, it has taught us a lot of lessons how to cope with all these challenges. In our present system and practices in education, particularly in these trying times of uncertainty, many of us would surmise that our education systems are not well aligned with the overall goal of learning. Other goals can detract from, and in some cases compete with, efforts to improve learning outcomes. We could also infer that the elements of an education system are often incompatible or incoherent. For example, our government funding allocation sometimes fail to provide the resources schools need to improve learning, and even the school funding is available. The rules governing its use often leave little flexibility for schools to use it in ways tailored to specific needs of students. What we can do is to become resilient. No, it's resiliency is actually the byword of the pandemic. No, to promote resiliency, no, as science teachers, no, we must consider our strengths and our assets in education communities and systems to support our students in making sense of the adversity they experience. I know that it's not only the students who are experiencing adversity, but also our teachers, our school administrators. We should find the very purpose in education and develop the needed skills and competencies. We need to upskill ourselves as well as teachers. Your collective participation in this kind of academic exercise can propel our mutual support and commitment to learning, because protection and well-being of our students, our staff, and our families that are affected by this great educational challenge is paramount. Well, to put emphasis, resilience matters because not only is learning and school success possible in spite of adversity, education can also be the vehicle to overcome the adversity. To Dr. Peñaflor, our CID chief, to Dr. Bermilio, and to all the participants, thank you very much for sharing to us your precious time to actively participate in this kind of activity, this half-day activity. I believe this will end until the Friday of this week. I hope all your sharings of experiences would give us feedback to calibrate and redirect our compass what to prioritize, because we value your observation, we value your inputs and recommendation to better improve our service. We want to make sense and find our purpose that in turn will allow us to make meaningful and positive decisions as we mold heroes in Bataan. Magandang araw po sa ating lahat. Pagpalain tayo ng dakilang Diyos at patuloy po kayong mag-ingat.
Sir, for your encouraging and heartfelt message, which lead us to keep the fire blazing in our hearts. This webinar series is a collaboration of selected science teachers. This is to provide a deeper and more comprehensive discussion on science content and teaching strategies.
Please take the opportunity to stay with us, dear participants. We must pay attention since, as usual, we will be given 20 item questions at the end of this webinar, which will also serve as our attendance for today.
To begin with, our first facilitator, I just want to ask if okay pa po ba ang lahat? I hope things are going well for you and that you are enjoying this webinar series dahil sigurado po kami na marami po tayong matututuhan dito. To discuss our topic on the different types of soil, our first speaker for today is a teacher 2 of Samal National High School. Let us lend our ears to Ma'am Miraflor B. Peralta.
To Division webinar series on science content and teaching strategies in the context of the most essential learning competencies for grade 4 science. I'm Ma'am Miraflor B. Peralta, Teacher 2 of Samal National High School, Maine. Our competency is to compare and contrast the characteristic of different types of soil. So are you ready to listen? Let's begin! Have you been to the Banawe rice terraces? The rice fields that comprise the terraces were carved by the Ipugaos with their hands. The terraces follow the natural contours of the mountain. Because of this, parts of Banawe rice terraces are recognized by the UNESCO as a World Heritage Site. The said terraces are suitable for farming because of their fertile soil. In our today's lesson, we will learn more about the different types of soil and their suitability for plant growth. Soil is everywhere. In any place you go, soil is present. It is in the river banks, in rice fields, in gardens, and even under the sea. Soil is not only important in farming and gardening, it also serves as habitat for various organisms. Soil is the top layer of Earth's surface. It is made up of organic matter, contain minerals, nutrients, liquid, and gases. How is soil formed? Soil is formed through the process of rock weathering. Weathering is the breakdown of rocks into smaller particles when in contact with water, air, or living organisms. Weathering may be mechanical and chemical. Mechanical weathering is the breaking down of rocks into pieces without changing its chemical composition. No new substance is formed. While chemical weathering is the breaking down of rocks as a result of a chemical reaction, and it leads to formation of a new substance. Different factors break rocks apart. These factors are called agents of weathering. How do living things affect weathering? Plants, people, animals can weather rocks. Some plant roots grow into rocks. As the root grow, they push against rocks and concrete that can lead to fracture. After some time, the rock cracks open. This eventually breaks rocks into pieces. Animals contribute to weathering too. When animals scratch rocks with their bodies, claws or hooves, rocks breaks and weathering occur. Some animals like earthworms and some insects burrow in the ground. This loosens and breaks rocks apart in the soil. Human activities like farming also break rocks. Heavy equipment and machines smash rocks to break them apart. In chemical weathering, rocks and minerals are reacting to acid, oxygen, carbon, and water. And in living things, when plants and animals die and decay, they are broken down by decomposers such as bacteria. Bacteria secrete acids that react with minerals found in rocks. The chemical reaction causes rocks to break into pieces. To truly understand chemical weathering and how it works, we need to look at examples of the different types of chemical weathering. First is carbonation. When rain goes through the air and into the ground, it grabs carbon dioxide, creating carbonic acid. This weak acid reacts with a calcium carbonate in stone when it seeps into the rocks. Second is oxidation. It occurs when free oxygen combines chemically with metallic elements like iron. Third is hydration. Hydration is a type of chemical weathering where water reacts chemically with the rocks, modifying its chemical structure. Fourth is hydrolysis. When rocks sit in water for extended period of time, they begin to break down and have a clay-like texture. Acid rain is water with sulfuric and nitric acids from the burning of coal and fossil fuels, along with a volcano eruption. The acid creates a reaction when they hit stone, causing the surface to wear and the composition to soften. Let's look at the different type of soil now that we have learned how they were formed. Soil varies from place to place. Some soil may be sand, silt, clay, and loam. How are they different from each other? Let us study the table. There are three soil particles, the sand, silt, and the clay. Sand particle is big. The size range from 2 to 0.5 mm. Its individual grains can be seen with a naked eye, but does not hold water. Its texture is rough due to the presence of coarse grain, and it is gritty, while the silt has a medium size. Its size range from 0.05 to 0.002 mm. The individual grains of silt cannot be seen with the naked eye. Grains are observable using magnifying glass. It can hold minimal amount of water, and it is a powder-like in texture. And last is clay. It is individual grains of clay cannot be seen with the naked eye, but it holds much water. Its texture, grains cannot be felt, and it is sticky. Let us proceed to learn more about soil types. Which of these plants grows on sandy soil? Silty soil, clay soil. Sandy soil is mostly found on beaches and seashore. It is the result of weathering and disintegration of the variety of rocks such as granite, limestone, and quartz. Sandy soil has a coarse texture. This implies that it has low water retention ability. Coconut trees and cactus are commonly grown on this sandy soil. Silt soil is a granular material made up of rock and mineral particles that are larger than clay but smaller than sand. Silt is created when rock is eroded or worn away by water and ice. As flowing water transports tiny rock fragments, they scrape against the sides and bottoms of the stream bed, chipping away more rock. Another type of soil is the clay soil. It is composed of a very small particles of weathered rock. It has poor water drainage. This means that water is absorbed slowly and is retained for a long time. The water clog in the soil limit the plant roots from getting oxygen. During rainy season, clay soil becomes very wet. Such conditions make it hard for plant to grow. During dry season, water evaporates, making the soil dry and hard and causes plant to wither and die. In small amounts, clay soil is necessary to make good soil. Plants with tough roots grow well in clay. The roots break off tough clay soils. Some plants that thrive well in this kind of soil include potato, cabbage, grass, and rice. The last type of soil is the loam soil. Loam soil is a soil mixture that has a good amount of sand, silt, and clay. It is the best soil for growing plants. In this mixture, the clay and silt helps retain the moisture, while the sand keeps the soil from compacting too much. Loam soil also contains humus. Humus is made up of decayed plants and animals' matter that helps make the soil fertile. Bamboo, ornamental plants such as roses, vegetables, and fruits grow on loam soil. That's all for the soil types. Let us try to answer the following question to see how well you understand the lesson. Did you get all of the questions right? I'd like to close this lesson with a quote from Dr. Charles E. Keeler. All life depends upon the soil. There can be no life without soil and no soil without life. They have evolved together. Thank you and God bless.
The floor. Indeed, beauty and brains talaga ang ating mga facilitators. So ano pa ang hinihintay natin? Just sit back and enjoy this day. Now, as I present to you our next discussant, a Master Teacher 1 from Cabcaben Elementary School, to discuss the different sources of water and its uses. Let us all welcome Ma'am Francia S. Quiro. Take it away, Ma'am.
Good day. I am Teacher 1 from Kapkaban Elementary School. Today's lesson objective is explain the use of water from different sources in the context of daily activities. How refreshing it is to have a glass of cold water after playing outside. Right, kids? But do you know where does water come from? That is the question that we will try to explore more on today's lesson. Water is a natural resource available in any living community. Most of us receive our water supply from water treatment facilities and water towers. When we turn the faucet on or fetch water from wells, we should be aware that these are just distribution mechanisms instead of sources. Here are the different sources of water. Rainwater. Rainwater is a major component of the water cycle. It is responsible for most of the fresh water on Earth. Rainwater is collected on Earth in the form of surface water and underground water. Uses of rainwater. It provides suitable conditions for different types of ecosystems, as well as water from hydroelectric plants and crop irrigation. What are the other uses of rainwater? Washing vehicles and equipment. Washing outdoor items is another excellent use for untreated water. Cars, garden tools, lawn mowers, and even the driveway and the sides of the house are all perfect candidates. Composting. Water is essential for proper decomposition of your compost pile. Make sure to water your compost with the rest of your garden. Water for wildlife, pets, and livestock. Rainwater is safe for pets and livestock to drink or to wash in, especially if you have a method to collect rainwater directly. Fire protection. A rainwater catchment system with a large storage tank could give you extra protection if you live in an area prone to wildfires. Make sure you also install a good pump so you can access the water quickly when needed. Next, we have surface water. Water present on the Earth's surface is found in different forms. We have the oceans, rivers, lakes, ponds and streams, and falls. These are called surface water. Surface water is classified into two. The first is salt water. It covers 97% of the water on Earth, has approximately 3% more dissolved salts, and they are found in seas and oceans. How are oceans and seas different from each other? Ocean, a large expanse of salt water that covers 3/4 of the surface of the Earth. Oceans are interconnected bodies of salt water where boundaries are established by lands of different continents. The Atlantic, Indian, Antarctic, and Pacific Ocean are the major oceans of the world. Sea. It is a body of salt water that is part of the ocean and has a land around partially enclosing it. Since it's a division of the ocean, seas are smaller in size compared to oceans. The largest seas include the South China Sea, Caribbean Sea, and the Mediterranean Sea. What are the uses of salt water? These saltwater sources are beneficial to humans, such as for recreation, for traveling, and maintaining natural cycles. On the other hand, salt water is not useful for drinking. Consuming it can actually harm humans. The second one is fresh water. It makes 3% of the water on Earth. It has less salt concentration. This water can be found in rivers, lakes, streams, and falls. Uses of fresh water. In the Philippines, one of the most popular lakes is Laguna de Bay. It is a large shallow body of fresh water in Luzon. Laguna de Bay is the source of fishes and provides a major transport route around the towns of Laguna. It also serves as a reservoir for flood waters to save Metro Manila from flooding during the rainy season. The waters of the lake are also used to generate power to limited extent. The third source of water is groundwater. Rain seeps into the ground and fills up the cracks or tiny spaces in fractured rocks and soil to form the groundwater. A well is used to extract water from it. A well is a hole drilled into the ground to access water from an aquifer. An aquifer refers to underground layers of rock that are saturated with water that can be brought to the surface through natural springs or by pumping. What are the uses of groundwater? It is a safe source of water. It is considered the cleanest water and contains a lot of dissolved minerals which the human body needs. Groundwater is used for drinking, bathing, cooking, watering crops, and many more.
Most people get their water from one of two places. City water is usually taken from surface water resources, treated, and piped to your tap. But if you live in an unincorporated area, you might be getting your water from a smaller on-site well. This water is from underground aquifers, also called groundwater. So, what is groundwater? It's water that collects or flows beneath the Earth's surface, filling the porous spaces in soil, sediment, and rocks. When we say something is porous, that means it has small spaces or holes in it, through which liquid can move. Porosity is an indication of how much water a material can hold. When we say something is permeable, that means it allows liquids to pass through it. Permeability is an indication of how easily water can move through a material. Materials like gravel and sand are permeable and porous. Water flows through them easily, and they can hold a lot of it. Materials like clay and shale are porous and can hold water, but their pores are so small that water flows through them very slowly, giving them low permeability. With this in mind, let's talk about aquifers. An aquifer is a saturated area of sediment or rock that groundwater can move through. Groundwater stored in aquifers can be brought to the surface using wells.
So you can imagine if you think about something like the Grand Canyon and you can see all those different layers, well, some of those layers hold water better than other layers. And so they're all sandwiched together and interconnected in various different ways. And because it's all underground, it's hard to know about how exactly they're interconnected, but they're stacked on top of each other. So when you drill a hole in the ground, you drill through some geologic formations that aren't holding any water, and then you can drill down into one that is.
We use wells, groundwater wells, for all kinds of purposes. So the typical shallow wells here in this vicinity would be down at about maybe 200 feet deep from the ground surface, but they're pumping water from 60 or 70 feet, and they're pumping it from a water table or unconfined aquifer largely.
So a confined aquifer, if you go back to imagining the stacks of different rock types, if you think of it like a sandwich, like if it's a BLT and it's a slanted BLT, then if the tomatoes are the water holding geographic feature, then the water flows down through the tomatoes. But if the bread is impermeable to water, the bread is then confining the aquifer in the tomatoes. And so because it's on a slope, water keeps pushing in, and so there's pressure on the water from the top of the hill to the bottom of the hill. And then the cool thing about a confined aquifer is if you drill down through the bread into the tomatoes, you can get water to come up under pressure. And an unconfined aquifer is just one where it has contact with the surface, and so there's nothing holding it in place.
Water that collects underground is held in an upper unsaturated zone and a lower saturated zone. The unsaturated zone is located directly beneath the land surface, and the pore spaces hold both air and water. In the saturated zone, all the open spaces are filled with water. The water table is the very top of the saturated zone and the bottom of the unsaturated zone.
Well, the saturated zone would be all of that soil, or whatever the lithology is at depth, that's below that surface water level, or we call it the free water surface, that you would intersect when you drilled the hole, say, and you dropped a float in, and you'd see this water standing, or like standing water. So it's all of the soils or lithology below that free water surface is considered saturated. There's a zone above that called the capillary fringe, or has some other names, or seepage face, that's also saturated but held there by capillarity. So like a capillary tube sucks water, like a straw, a thin straw, out of a beaker. The capillary fringe holds water in the saturated, it saturates the soil there, or nearly saturates it. Above it, the soil begins to desaturate, associated with the capillary pressures in the water, in the soil water, until when you come near the surface, it's relatively dry if we're away from wet areas.
Water table is just sort of the common word that people use to refer to aquifers, but it's a little bit confusing because it sort of implies that there's some sort of table underneath there, and it's just this giant lake underground. And because of the way rock formations are formed and interlayered, it's not really the way things are. And so while basically when people say water table, they're talking about the depth that you have to drill down to hit water.
What does it mean to recharge the water table?
You can think recharge the groundwater table is basically put water into that aquifer. It's like imagine if you had a glass full of sand, and you could pour water into that glass, even though it's full of sand, because there's all the little holes in between the sand bits. And so you could pour water in there, and then if you drill the hole in the bottom, water would just leak out the bottom. And so the more you pour water in the top, the more you're recharging the ground table, or filling up that aquifer.
Let us summarize what you have learned today using a graphic organizer. The different sources of water are rainwater, groundwater, surface water. Try to answer the simple exercises. Good job, kids! Let us try another one. What source of water is used in the following activities? Choose your answer from the box below. Good job, kids! This has been your teacher, Francia, leaving you with a simple reminder. Keep calm and stay hydrated. Goodbye!
That was very comprehensive explanation of your topic. Talaga naman nakita natin kung paanong pinaghandaan ng ating mga facilitators ang kanilang mga topic for today. So, ano pang hinihintay natin, partner? Ipapakilala ko na ang ating next discussant. In addition to our mic content, here is our next speaker to discuss her topic on weather instrument. She is a Master Teacher 1 of Luwakan National High School, Maine, Ma'am Nancy P. Macaraig.
Good day, my dear science teacher. Today, we are going to have another significant activity that is useful in improving and delivery of learning to our students in science content and teaching strategies. I am Nancy P. Macaraig, your teacher in science from Luwakan National High School. For today's objectives, describe the different weather components in a weather chart. Use weather instrument to measure the different weather components. Have you experienced going out for a day with the sky that is clear and unexpectedly it rains? Did it ever cross to your mind why we have storms and why people can track their location and speed? Then what do you think is the phenomena behind it? This is all because of weather. I want to know what is your idea or what comes to your mind when you hear the word weather. Studying about the weather is important because it affects our day-to-day activities. That is why people must be aware of daily weather so that they can plan things well. So, what is the meaning of weather? Let us read and study this sample weather forecast. Now that you are done reading the given weather forecast, can you answer the following questions now? 1. Is weather condition the same in all places? 2. What is weather? Weather describes the condition of the air at a particular time and place. Weather also tells how the air moves or wind and describes anything it might be carrying, such as rain, snow, or clouds. Thunder, lightning, rainbows, haze, and other special events are all part of weather. Weather is the condition of the atmosphere at any given time. Now, look at the pictures below. Which among the pictures below shows a weatherman? Is it A, B, C, or D? What does a weatherman do? In science, what do you call a weatherman? What made you say that he is a weatherman? Meteorologists are scientists who study and work in the field of meteorology. What do you call the person who to study the weather. We call them meteorologists. Everybody say, meteorologist. He gathers information and reports it to the people. He also helps trace weather disturbances through the use of different weather instruments. Now let us have an activity. Can you identify the following weather instrument? Are you ready? Let us begin. Do you have your answer? Great! The answer is thermometer. Let's have the second one. Are you ready to find out the answer? Good job! The correct answer is rain gauge. How about the next one? Are you ready to find out the answer? Very good! The correct answer is wind vane. How about the next one? Let us check your answer. Very good! The correct answer is barometer. And for the last one, do you have your answer? Let's see. The correct answer is anemometer. Using a variety of weather instruments, maps, and reports, meteorologists study the ever-changing weather information in order to discover trends and patterns which help them forecast the weather for the next few hours and days. Meteorologists can now give advance warning on extreme weather conditions so that communities can prepare for the worst. Weather components in a weather chart are temperature, humidity, wind speed, wind direction, pressure, rainfall, and cloud cover. To describe those weather components, we have these weather instruments. Air temperature and thermometer. Thermo means heat, measures the amount of heat energy in the atmosphere. Heat comes from the solar radiation that was absorbed by the ozone layer in the stratosphere and goes into the air. Then the air temperature is measured by the thermometer. This thermometer is used to measure air temperature. It is a hollow glass tube with a liquid, alcohol or mercury inside. When the air temperature is high, the liquid inside expands or goes up, but when the air temperature is low, the liquid goes down. Can you read this thermometer? In reading the thermometer, it should be at eye level. Read off at bottom of the index and it can be reset with magnet. Air temperature is measured in degrees Celsius. Although there exists Fahrenheit, degree value on the other side. Humidity and sling psychrometer. Psychro means cold. Therefore, psychrometer measures the amount of water vapor in the air. When the air is nearly completely filled with vapor, it feels muggy if the air is hot. What word would you use to describe humidity? Hygrometer measures the water vapor content of air or humidity. On the other hand, sling psychrometer measures relative humidity using the cooling effect of evaporation. Two thermometers are used in a sling psychrometer. In reality, there is no difference between hygrometer and psychrometer. A psychrometer depends on the oldest method to measure humidity. However, hygrometer uses a totally new digital approach. How humid is it? If the relative humidity of the air is 88, how would you feel outside? Humidity is the amount of water vapor in the air. If there is a lot of water vapor in the air, humidity will be high. The higher the humidity, the wetter it feels outside. On the weather reports, humidity is usually explained as relative humidity. When the air has a high moisture content, as is the case is humid weather, this sweat cannot evaporate, leaving our bodies feeling hot and sticky. To cool off, our bodies must work even harder. This results in excessive sweating, increased rate and depth of blood circulation, and increased respiration. Wind speed and anemometer. Anemo means wind. Measure the wind speed in the air. The cups catch the wind, turning a dial attached to the instrument. The dial shows the wind speed. It measures in kilometer per hour. Changes in the heating of the Earth's surface or uneven air temperature and air pressure cause air to move. Horizontal or side-to-side movement of air is called wind. Vertical or up and down movement of air is called air current. And wind speed is measured by anemometer. As wind is caused by warm air, it rises because it is less dense. Cooler sinks because it is more dense. This pattern is called convection cell. Wind vane is an instrument that determines wind direction, from which the wind is blowing. Air pressure and barometer. Baro means weight. A barometer works by measuring the amount of force exerted by the air's molecules hitting a surface area. Barometer is measured in millibars. When air heats up, the molecules spread apart and become less dense, and the air pressure goes down, becomes low pressure. Reading a barometer, it tells whether or not the pressure is rising or falling. A rising barometer means sunny or dry conditions, while falling barometer means stormy and wet conditions. Can you read this barometer? Standard air pressure is 1013.25 millibars. Does this barometer read at standard air pressure? The reading of the barometer, which is 1018 millibars, the weather is at most of sunny or dry conditions. Rain gauge measures the amount of rain that has fallen over a specific time or period. Rain gauge should meet the following conditions: seating factors, clear view of sky, recess into ground, approximately 30 cm above ground, grassy surface or avoid splashback, read off at eye level, regular intervals, or 24 hours. Another weather instrument is weather map. It indicates atmospheric conditions above a large portion of the Earth's surface. Next, weather satellite. It is used to photograph and track large-scale air movements such as typhoon, hurricane, etc. Weather charts have lots of symbols and information. We have two existing pressure systems: high pressure or typically fair weather, low pressure, typically cloudy, unstable conditions, or bad weather. In the Philippines, we have two wind systems: northeast monsoon from November to February, southwest monsoon from July to September. What can you say about the different instruments used by meteorologists? Do you think they are helpful? In the past, How do people think and talk about the weather? What instrument do they use? Our eyes are one of the best ways to help detect the weather. Always keep an eye at the sky, and you'll usually be on top of weather conditions. It is really fun to know these different instruments. Did you know the different countries have their own weather stations? Weather station is the place where all data about the weather are being gathered and evaluated. They are also the one who is responsible in informing the people about the daily weather conditions of the country. In the Philippines, we also have our own weather station. Do you know what it is? In the Philippines, we have a weather stations that give the daily weather report and observation. We call it Pag-asa. What is the meaning of Pag-asa? Pag-asa means Philippine Atmospheric Geophysical and Astronomical Services Administration. Pag-asa is a Philippine national institution dedicated to provide flood and typhoon warnings, public weather forecast and advisories, meteorological, astronomical, climatological, and other specialized information and services primarily for the protection of life and property and in the support of economic, productivity, and safety. Let us see if you really learned something today. With the partner or pair share, complete the concept map below in your notebook. You are given time to do this. Then be ready to share your work to the class. Now, on your next activity, choose your answers from the box, which corresponds to the descriptions of the weather instrument. That is all for this topic. Thank you, science teachers. God bless and keep safe.
Thank you so much, Ma'am Nancy. Wow! As in wow talaga, partner. Ang dami ko na namang natutunan ngayong araw na ito. Sigurado ako, gayon din ang ating mga viewers for today. Kaya naman hindi ko na pakakatagalin pa. Now, let us hear another interesting topic about lights and shadows to be discussed by Ma'am Billorita M. Mercado, Teacher 3 of Bagak National High School. Take away, Ma'am.
A pleasure to each and everyone. This is Teacher Villorita M. Mercado from Bagak National High School, your facilitator. For our most essential learning competency, describe the changes in the position and length of shadows in the surroundings as the position of the sun changes. So our lesson for today is about lights and shadows. Every day when we go to school, we see so many things around us. During the day, we get a sufficient amount of light from the sun, which allows us to see the objects clearly. But when you enter a dark room, you'll not be able to see the objects around you because there is no light present there. You can see things in the dark only when you switch on the light. Light is one of the most important things that is required to see objects around us. Light is a form of energy called electromagnetic radiation. Electromagnetic radiation comes from the sun and other sources. Light is made up of photons, which is the basic of all light. Let us try to find out the different properties of light. Number 1, light travels in a straight line. Second, light travels much faster than the sound. For example, thunder and lightning starts at the same time, but we will see the lightning first. Another example is when a starting pistol is fired, we see the smoke first and then we hear the bang. Third, light travels very fast, about 300,000 kilometers per second or 186,000 miles per second. At this speed, light could travel the equivalent of 8 times around the world in 1 second. Fourth, light can create shadows. We see things because they reflect light into our eyes. This is literally the only way we get to see things. All objects we see either create light or reflect light. Before we move on, let's have a brief summary of the properties of light. Number 1, light travels in a straight line and is a form of energy. Second important information, light travels much faster, 1,000,000 times faster than sound. Third, we see things because they reflect light into our eyes. Fourth, shadows are formed when light is blocked by an object. Fifth, visible light is only a small part of the electromagnetic spectrum. The other facts are invisible to the human eye but not necessarily the eyes of other animals. Since we are talking about light, what do you think is our major light source? Yes, correct. Our major light source is the sun. Where else does light come from? Light comes from natural and man-made or artificial light. I have here pictures of moon, water, and mirror. Do you think they are light sources? No, these items are not light sources. Instead, they are reflecting light from other sources. Let us try to discuss how do we see things. So let us try to find out the procedures. First, light coming from object enters the eye through the cornea, then the pupil. It is focused clearly by the lens on the retina. The light-sensitive cells of the retina gather information about patterns of light and dark color and movement and send it through the optic nerve. Information entering the brain through the optic nerve is then transmitted through more nerve pathways to the visual cortex. Here, the patterns of light and dark color and movement are interpreted. Finally, the brain, based on past experiences, can then understand what it sees. And those are the processes on how do we see things. We already know how do we see things. Now, let us try to discuss how do we see color. Light from most light sources looks white, but actually it contains all the colors of the spectrum known as the rainbow. If an object looks blue, it is absorbing every color except blue, which is reflecting off, entering your eyes. If an object looks orange, it is absorbing every color except orange, which is reflecting off and entering your eyes. If an object looks red, I bet you get the idea. How does light reflect? The angle of reflection is always equal to the angle of incidence. Light can only be reflected in a straight line. Let us check some facts about light and shadows. A shadow is formed behind an object when it blocks the light. Some light can pass through translucent materials such as sunglasses. The sun is a source of light. The moon is not a source of light.
We can see it because it reflects light from the sun. A mirror is highly polished and reflects light. We can see images of ourselves and other objects in mirrors. Lights blocked by opaque materials like mug. Next, number 6. Clear glasses is transparent and allows all light to pass through. 7. A periscope has two angled mirrors that reflects the light. This enables us to see around corners. Let us further discuss these facts about light and shadows. Light acts both as wave and particle, depending on the kind of matter it comes into contact with. Light will act differently. There are 3 different types of materials that light will or will not pass through. They are the transparent, translucent, and opaque. Transparent objects. These objects allow light to pass through them. One can clearly see through transparent objects, and transparent objects do not cast shadows because they do not block light. Examples of transparent objects are glass, lens, clean plastics, diamond, clear cellophane sheet, water, and air. While opaque objects do not allow light to pass through them. One cannot see through opaque objects, and opaque objects cast dark shadows as they block light completely. Examples of opaque objects are apple, brick, cup, stone, and can. Translucent objects, on the other hand, allow light to pass through them partially. One can see through translucent objects but not very clearly. Translucent objects cast faint shadows as they block light partially. Example of translucent object is a frosted window panel. And those are the different materials that allows or do not allow light to pass through them. One day, on a hot sunny day, while you are walking, you notice that you are not alone. And everywhere you go, there is this black image formed on the ground which imitates your movement. Don't be afraid, because this black image formed on the ground is actually called a shadow. A shadow is a dark shape made when some objects block the light. You must have a source of light in order to have shadows. Any object, living or non-living, that can block light can cast shadows. But how does light form shadow? Light rays travel in a straight line, radiating out from the light source. If rays are blocked by an opaque object, a shadow forms where the light cannot reach. If the light source is more closer to the object, more light is blocked and a longer shadow is formed. You can have many number of shadows depending on the number of light sources. Shadows keep changing throughout the day. How does sunlight cause shadows? The position of the sun affects the position and length of the shadows created. Looking north, the sun appeared to rise in the east and travel across the sky until it sets in the west. Thanks to this natural phenomenon, a sundial is able to tell us the time as long as it is sunny day. As I've said earlier, shadows throughout the day changes. In the early morning, the sun is low in the sky, so the shadows are long. It is longest in the early morning and in the late afternoon. At noon, when the sun is directly overhead, shadows are short or there is no shadow at all. The sun changes throughout the day, which changes the angle which the sun's rays fall on the ground. This is the reason why you see different size and shapes of the shadows. The angle at which a light strikes an object affects the size and shape of its shadows. Shadows are longer when the light source is at low angle or side-on, and the shadows are shorter if the light source is at higher angled or overhead. While there are factors that affects the size of the shadows. Number 1, the size of the shadow depends on the size of the object. Second, the distance from the light to the object. Third, the distance from the light to the screen. In addition to, the tilt of the Earth's axis affects the length of our shadows. During the summer, our location is tilted towards the sun, so our midday shadows are very short. During winter, our location is tilted away from the sun, so our midday shadows are longer. Let us describe the positions of Earth and the sun when it is daytime. How are they different at night? As Earth rotates on its axis, the different locations on Earth change in position in relation to the sun. A city on Earth that faces toward the sun at noon will rotate to face away from the sun 12 hours later. The positions of Earth and the sun over the course of a 24-hour rotation cause sunrise, sunset, day and night. At all times, half of Earth faces toward the sun, and half faces away from the sun. The half that faces toward the sun is illuminated by the sun's glow. It is daytime on that half of the planet. At the same time, the half of Earth that faces away from the sun is in darkness. It is nighttime on that half of the planet. As Earth rotates, the sun-facing half steadily moves from sunlight into darkness. From our position on Earth, this appears as sunset. Meanwhile, the dark-facing half of Earth steadily moves into the sunlight. We see this process as sunrise. On Earth, it looks like the sun is moving across the sky. Why is this not true? Throughout the day, the sun appears to move from east to west across the sky. In reality, Earth is rotating from west to east. Shadows offer some evidence to support this. You can see the apparent motion of the sun and the movement of shadows during the day. When the sun appears to rise above the eastern horizon in the morning, its light casts long shadows that point to the west. As the sun takes its arc-shaped path across the sky, the shadows change. As the hour approaches noon, the shadows become shorter. When the sun is directly overhead, very little shadow is observed. As the day continues, the sun appears to move toward the western horizon. Again, the shadows lengthen, but now point toward the east. Before clocks and wristwatches were invented, people used the sun's apparent motion to tell time. A sundial uses shadows to determine the time of the day. Let's have a summary on how our shadows formed. Number 1. When the sun shines on the pole, a shadow of pole is cast. Second, at different time of the day, the shadow will be at different place and the shadow will have different length. Number 3, the rotation of the Earth on its axis causes the position and the length of the shadow to change. 4, If an object is placed in an open space, the length and the position of the shadow changes from the west to the east. Shadows are formed when an opaque object is placed in the path of light. Next, shadows are also formed because light travels in a straight line and cannot bend around the opaque object. Thus, a region of darkness where the light cannot reach is formed. Next, the size of the shadow depends on how much light is being blocked by the opaque object. Did you know that there are also types of shadows created by the celestial bodies? And these types of shadows are called the umbra, penumbra, and antumbra. Umbra is the darkest portion of shadows, while penumbra is the edges of the shadow, and antumbra is the shadow at the edges of umbra. You get different types of eclipses depending on the position of shadows. Let us try to find out on what different eclipses you see according to which part of the shadows you're in. If the Earth and the Moon is found in umbra, you get a total solar eclipse, total lunar eclipse, and partial lunar eclipse. During a total lunar eclipse, the entire moon enters the umbra. A partial lunar eclipse occurs when the umbra covers only part of the moon's surface, while a penumbral lunar eclipse occurs when the moon enters the Earth's penumbra. Thus, we get a partial solar eclipse, partial lunar eclipse, and penumbral lunar eclipse. While in antumbra, we get an annular solar eclipse. Do you know that we can calculate the length of a shadow? Shadow Length Calculator is an essential online tool which calculates the length of the shadow projected by an object due to the sun. The tool uses the angle of elevation to find the length of the shadow of an object. To calculate the shadow of an object, the angle of elevation is also required. How do we measure height by shadow? To measure height by shadow, we multiply the length of the tree shadow by your height, and then divide the resulting number by the length of your shadow. For example, if you are 5 feet tall, your shadow is 8 feet long, and the tree shadow is 100 feet long. The height of the tree is 100 times 5 divided by 8 is equivalent to 62.5 feet. Before I end my discussion about light and shadows, let's have these interesting facts about light and shadows. 1. A shadow happens when an object blocks the sun's rays. Shadows are longer in the winter because of the angle of the sun. Second fact, your shadow is longest in the early morning and in the late afternoon. In the afternoon, when the sun is directly above you, your shadow leaves your side for a little while. The sun makes the longest shadows at the beginning and at the end of the day because at that time, the sun is lowest in the sky and aimed at the sides of the various things on the earth. When the sun is directly above you, there is little or no shadow because the light from the sun is falling upon you from all the sides and there is hardly any dark region. A long time ago, people observed the way shadows were formed by the sun and utilized this principle in making the world's most primitive clocks, the sundials. Fourth, the first person to calculate the size of the planet Earth with a high degree of accuracy used simple geometric equations and measurements of shadows. Eratosthenes, the head librarian of the Great Library of Alexandria, performed this feat over 2,000 years ago around 250 BCE. Another fact: any object, living or non-living, that can block light can cast shadows. Next, the smaller the angle between an elongated object and the direction of the light is, the shorter the shadow. On the other hand, the smaller the angle between the direction of the light and the surface on which the shadow occurs is, the longer the shadow. If the object is closer to the light source, the shadow is large. If the surface is curved, there are further distortions. For non-point sources of light, the shadow is divided into the umbra and penumbra. The wider the light source, the more blurred the shadow. If there are multiple light sources, there are multiple shadows, with overlapping parts darker. For a person or object touching the surface, like a person standing on the ground or a pole on the ground, these converge at the point of touch. And those are the different interesting facts about light and shadows. Allow me to end my discussion with the saying from Billy Graham, and I quote, "All the masterpieces of art contain both light and shadow. A happy life is not one filled with only sunshine, but one which uses both light and shadow to produce beauty." A pleasant afternoon to each and everyone.
That was interesting topic, Ma'am Villorita. Thank you for sharing your knowledge with us. At syempre, hindi po matatapos ang ating webinar series kung wala pong demo teaching. So, it gives me great pleasure to introduce to you our energetic demo teacher for today on her topic, Lights and Shadows, a teacher 3 from Duale Elementary School, Ma'am Rizalyn D. Cruz.
Hello kids! How are you today? I am Teacher Risa and welcome to our science class. Are you ready? Let's go! Listen carefully and join me in exploring light and shadow.
For today's learning objective, at the end of the lesson, you should be able to: Number 1, describe how shadows are formed. Number 2, describe the changes in position and length of shadows in the surroundings as the position of the sun changes.
Before we go on, let's have a short review. Identify what is being described by arranging the letters.
Number 1, it is a form of energy made of photons. A photon is the smallest unit of visible light. Light. Very good. Number 2, it is the main source of heat and light on Earth. Sun. Correct. Number 3, light travels in a straight line. Very good. Number 4, it is when light bounces off an object? Reflection. Very good. Number 5. It is the bending of light as it travels from one type of material to another. Refraction.
Very good, class. You mastered our previous lesson. Now, let's move on.
Let us watch a short story, Light and Shadows, then answer the questions that follow. Light and Shadows. This is Andy. Say hello to him. Andy is 9-year-old. He loves science just like you. One morning, Andy misses the school bus and has to walk to school. On the way to school, he realizes that his shadow is very long. It is even taller than him. Maybe hopping will make my shadow even longer. So Andy starts hopping to school. During his recess, Andy notices his shadow is shorter than in the morning. It is about the same height as him now. On his way home from school, Andy looked very carefully at his shadow. His shadow has become really short. Andy begins to worry. Oh no! Oh no! My shadow is growing smaller and smaller under the sun. It is going to disappear. Andy is really very worried. Andy couldn't wait for his daddy to come home. Andy ran out of the house to find his daddy. To his surprise, Andy sees that his shadow hasn't disappeared. It is as tall as the shadow in the morning. Andy is glad that his shadow did not disappear. The sky gets darker as Andy walks home with his daddy. Andy notices that his shadow becomes lighter as the sky gets darker. Andy is puzzled by what he sees. Just as he is wondering, the street lamps light up. Andy sees 3 of his own shadows. Oh no! Does that mean that there are 3 of me right now? That night, Andy cannot fall asleep. Andy cannot help to think about his shadows. How is shadow formed? What causes the size and position of the shadow to change? What is the relationship between the length and position of the shadow and the time of the day? Based on the position of my shadow, how can I tell where is the light source? Can you help Andy to find the answers?
Andy is very curious about his shadows. Can you help him answer all his questions? That's great! But before that, let's see if you understand the story by answering the following questions.
Who is the character in the story? It is Andy. What did Andy notice about his shadow on his way to school? Andy notices that his shadow is very long. At what time did Andy notice that his shadow was very short? At 12 noon. Why does Andy feel worried? Andy is worried because he thought his shadow will disappear. What did Andy found out when he went outside at 5:30 p.m.? Andy found out that his shadow did not disappear, and it is as tall as the shadow in the morning.
Well done, kids! Now, we are ready to help Andy to answer all his questions. For Andy's first question, how is shadow formed?
Light is a form of energy made of photons. A photon is the smallest unit of visible light. Light travels in a straight line. When the light reaches an object, it reacts differently depending on the kind of matter it comes into contact with. These objects can be transparent, translucent, or opaque. Let us watch this video.
Objects are classified as transparent, translucent, or opaque depending upon their treatment of light. Objects that allow light to pass through them are called transparent objects. Most of the light falling upon a transparent object passes through it to the other side, thereby allowing us to see through them. Glass, clean air, pure water, etc. are examples of transparent objects. Objects that do not allow any light to pass through them are called opaque objects. As a result, we cannot see through them. When light falls on an opaque object, its shadow is formed on the other side of it. Wood, sheets of metal, dark-colored plastics, rocks, etc. are examples of opaque objects. Objects that are partially transparent and partially opaque are called translucent objects. They allow light to pass through them in a scattered or diffused manner. Frosted glass, tracing paper, greased paper, etc. are examples of translucent objects.
To form a shadow, there should be a source of light. It can be a natural light, like the sun, or an artificial light, like flashlight, bulb, and candles. And an opaque object, like trees, houses, toys, and even us. Remember, shadow is formed when straight light rays are blocked by an opaque object.
For Andy's question number 2, 3, and 4, let us have an experiment. Experiment time! Because of the pandemic, it is not safe to go out. So, let us do our activity inside the house. We are going to improvise.
Before we start, here are some simple reminders. Number 1, listen carefully to the teacher. Number 2, follow the directions. Number 3, be observant. Number 4, take down notes the important details. Number 5, ask the help of your family members. To answer Andy's question number 2, what causes the size and position of the shadow to change? Let's do activity 1. What do we need? Flashlight, any assorted objects with different sizes and shapes that can be found in your house like pencil, cup, orange toy, Rubik's Cube, a rubber ducky, and a wooden block. The flashlight is our source of light. Let us place the objects one by one in front of our source of light. Observe their shadows. As we observe, the shadows have different sizes and shapes. It depends upon the object that casts the shadow. The bigger object makes bigger shadows. The smaller object makes smaller shadows. Can we change the size of the shadow? Let us move the object closer to the light source. As we move the object closer to the light source, the shadow becomes bigger and bigger. Now, let's move the object away from the light source. The shadow becomes smaller and smaller. Now, try to move the source of the light in any direction. Observe the position of the light source and the position of the shadow. You can see the direction of the shadow is opposite to the source of light. The source of light is going to act on the object. The object is blocking the light and giving a shadow on the other side. So this is clear that the direction of the shadow is always opposite to the source of light. Based on our activity number 1, the answer to Andy's question number 2 is the size and position of a shadow change according to the position of the light source. For Andy's question number 3, What is the relationship between the length and position of the shadow and the time of the day? Let's do activity 2. In this activity, we are going to see the change in size and direction of shadow. For this, we need a plain paper. Draw 4 lines showing the direction east, west, north, and south. And mark these points with equal distance into the center point. 8 a.m., 10 a.m., 12 p.m., 2 p.m., 4 p.m. We are going to see at different times of the day how the shadow is going to change. Choose one object and put it at the center. Then choose a light source that will act as the sun. It can be a flashlight from a mobile phone. Turn off the light of the room to see the shadow clearly. Then let's start. The sun rises in the east and sets on the west. When early morning, the sun rises in the east, you can see the direction of the shadow is just opposite to the light source. The object blocks the light and casts a shadow on the other side. The direction of the shadow is always opposite to the source of light. The sun is going to start moving, and as it reaches around 8 a.m., mark the length of the shadow. You can ask the help of your family members. And when it reaches 10 a.m., mark the length of the shadow. At 12 noon, the sun is directly overhead. Mark the shadow. And it reaches 2 p.m. Mark again the shadows. Mark again the shadows at 2 p.m. And then at 4 p.m., mark the shadow, the length of the shadow. And finally, the sun sets in the west. Turn on the light. Now we can see which has the longest shadow. It shows that the longest shadow is early morning, around 8 a.m. and 4 p.m. And the shortest shadow is at 12 noon, which is the sun is exactly overhead. Based on our activity, we can see the relationship between the length and position of the shadow and the time of the day. Sun, as the source of light, is constantly moving across the sky as it rises in the east and sets in the west. The sunlight strikes at the objects in different angles and affects the length and position of the shadows. In early morning, the sun is in the east side, the shadow cast on the west side. The sun's light rays are slanted as they hit the ground, so longer shadows are formed. At noon, when the sun is high or nearly above the horizon, shorter shadows are formed. In early evening, The sun is in the west side. The shadow casts on the east side. The sun's light rays are also slanted as they hit the ground, so longer shadows are formed. For Andy's last question, based on the position of my shadow, how can I tell where is the light source? As we observe in our two activities, the direction of the shadow is always opposite to the source of light.
Trivia time! You can have multiple shadows. It all depends on the number of light sources. The more the number of lights, the more shadows you will have.
Great job! We answered all Andy's questions.
Now, answer the following exercises to see if you understand our lesson for today. Exercise 1. Read the situation. You and your friends plan to have your lunch in a big tree at your school ground. You are the one assigned in putting up the mat. On what side of the tree will you place the mat? A, B, or C? Letter C. Exercise 2. Identify what will be the position of the shadow on the picture based on the position of the sun. Click the picture of the correct answer. Number 1. What will be the position of the shadow? A, B, or C? Letter B. Number 2. What will be the position of the shadow? A, B, or C? Letter C. Number 3. What will be the position of the shadow? A, B, or C? Letter A. Number 4. What will be the position of the shadow? A, B, or C? Letter A. Number 5. What will be the position of the shadow? A, B, or C? Letter C. Very good, class. Let us have a recap. Shadow is formed when straight light rays are blocked by an opaque objects. The sunlight strikes at the objects in different angles and affects the length and position of the shadows. For our evaluation, write true on the blank if the statement is correct and false if not. You have 2 minutes to answer this. Your timer starts now. Now, you can check your answers. For your additional activity, you can play with your shadow. What to do? Number 1, close the windows and door of your room. Number 2, bring your fingers near the wall. Number 3, ask someone to switch the flashlight on your fingers, forming some shapes like the head of the dog. This is the end of our lesson. Thank you so much. Goodbye, class.
Thank you, Mo. Now, to give you our last but definitely not the least equally beautiful and brainy discussion for today, let us all welcome Ma'am Leia Di Policarpio, Teacher 3 of Bataan Elementary School, to discuss strategies in teaching science lessons. Good afternoon po, ma'am.
Pleasant morning to all for science. I am Leia Dizon Policarpio, and I'm here to discuss about the strategies in teaching science lessons for the fourth quarter. We all learn differently based on our learning style, multiple intelligences, and past knowledge and experiences. We learn best when we experience a teaching approach that matches our unique learning profile. For this reason, educators need to use a variety of teaching strategies to assure that they are meeting the needs of their learners. Science is fun to teach, but the biggest challenge for us teachers is to make each teaching learning activity interesting for our youth that they will look forward to learning about science lessons every day. If these teaching learning activities are effective, students can reach the goals of life by acquisition of knowledge, skills, and values in science. As science teachers, we have already attended a lot of seminars and trainings. We have read and watched a lot. But the big question here remains the same. How can we really teach science effectively? Based on research, teaching will be more effective if teachers will do the following. 1. Present science as a way of finding out rather than as a body of facts to be memorized. Allowing learners to discover and to organize the information, equip them with problem-solving and decision-making skills. It also results in knowledge that is more easily remembered and recalled than rote learning. 2. Emphasize learning by doing. A number of researches show that learners learn better when they are personally involved in physical or hands-on activities. 3. Adapt science experiences to the learner's developmental needs. Learners differ on how they operate mentally. Therefore, you must arrange experiences that fit what they can do. 4. Use a variety of approaches in teaching science. Students have different learning styles. To be more effective, you must be aware of their learning styles and you must consider them in choosing which teaching methods to use. But what are the things to consider in choosing the effective strategies in teaching science? It is very important that teachers consider their learners' learning style in choosing and developing teaching strategies that they will use in teaching science lessons. Before we proceed to the strategies per se, let us first discuss about understanding how learners learn. Teaching strategies will be effective if we will always bear the following in mind. 1. Learners learn and develop as a whole person. The learner's cognitive, affective, physical, social, and emotional areas are intricately intertwined. Learners cannot grow in one area without affecting the other areas. 2. Learners grow through the same predictable stages but at different rates. This means that children of the same age group may not exhibit uniform characteristics. Some may be more intellectually or socially advanced than the others in the same age group. 3. Learners learn best through active involvement with concrete experiences. Research studies show that the use of hands-on activities can result in significant improvements in academic performance and attitude of students toward science. 4. Learners are curious and eager to learn. When the teacher fits the learning environment to learners' interests, needs, and their level of maturity, they become highly motivated. And finally, learners have different learning styles. Learning styles are preferred ways that different individuals have for processing and responding to environmental stimulus. Learning styles are also referred to as cognitive styles. After days of research and reading, allow me to present to you now the strategies and activities that you can use in teaching science lessons for the fourth quarter. The competencies are: compare and contrast the characteristics of different types of soil, explain the use of water from different sources in the context of daily activities, use weather instruments and describe the different weather components in a weather chart, and describe the changes in the position and length of shadows in the surroundings as the position of the sun changes. Here are the strategies in teaching characteristics of different types of soil. The first one is cut and paste activity. As you can see in the picture, this is fun and engaging way to practice determining different types of soil: sand, loam, and clay. Students will read a characteristic and determine which type of soil it is, then glue the box in the correct column. You will be needing the following: worksheets, printables, and their interactive notebooks. The second one is the soil exploration book. This is a great tool for them to record their observations on soil samples. It includes exploring with sand, loam, and clay soil. The materials are the exploration book and the soil samples. The third and final strategy for our first competency is the use of task cards. These soil task cards are a fun, low-prep tool for reviewing soil formation, types of soil, and layers of soil. Using these task cards, you will save time planning your review activity, and students will have fun reviewing what they have learned. The materials are task cards, pictures, and printed questions. Let us now move on to the strategies in teaching the use of water from different sources in the context of daily activities. Children should know where their water comes from. It should be given emphasis that depending on where we live, we may get our water from the ground, from surface water, or maybe even from rainwater collection. The first strategy is creating a model representing bodies of water. This activity creates a model representing bodies of water found on Earth. As they draw a pond, lake, river, and ocean, the students build vocabulary. Just imagine their level of engagement as they use a magnet to move their ship in the ocean and up to a river passing a lake and a pond. It's fun to those kids who love art, and it's educational and meets the curriculum goals at the same time. The next one is making an anchor chart. This strategy helps students to sort facts about each source of water. They will also improve their vocabulary as they write information about the water source. Anchor chart can help students make connections between new content and previously learned content. It is so named because it serves to anchor the students' brains with each key lesson you teach. The materials are cardboard, colored paper, and marker. Our third and final strategy in teaching the use of water from different sources in the context of daily activities is the virtual field trip. Virtual field trip lets students go anywhere at any time. Research say that this strategy can provide the same learning benefits that an actual trip does. This will help the students get familiarized with each water source and absorb details as if they are on the actual field trip. You will be needing ICT and videos or clips of the bodies of water. And we're now in our third competency, weather instruments and the different weather components. The first strategy is making a concept map. A concept map is a special form of a web diagram for exploring knowledge and gathering and sharing information. It is employed to develop connections among concepts in the unit. A concept map consists of nodes or cells or links. The nodes contain the concepts and are usually enclosed in a box or circle. The links are represented by arrows. The labels in the links explain the relationship between the nodes. The materials are cartolina, colored paper, and marker. And here's the sample of our concept map about weather. The second strategy for our third competency is journal writing. It allows the students to reflect or process their thoughts about science concepts. Journals may be in the form of workbooks, diaries, logs, or progress profiles. Journals make the students look back over their recent learning. And the third and final strategy for our third competency is the use of puzzles. By matching the weather word with a picture of the instrument and the definition of what it does, students can gain confidence in an important and sometimes challenging skill. Your students will love to practice and learn about weather instruments and vocabulary words with this activity. The materials are puzzles of weather instrument and element puzzles. We're now down to our final set of strategies for our fourth and last competency, the changes in the position and length of shadows. The first strategy is the use of shadows task cards. Teach your students all about shadows using these task cards. The task cards challenge your students with questions about shadow length and direction, Earth's rotation, sunrise and sunset, time zones, and more. This can also be used as test review. The second one is investigating shadows. In this activity, students are introduced to basic physical world concepts about light through the use of play and exploration. It identifies key science concepts and ways in which students can explore, experiment, and build their understanding of light and shadows. They can use cell phone, flashlight, spoon, or other materials. And finally, our third and last strategy is what we call the human sundial. This is an outdoor science experiment. These are hands-on activities for children to help them learn how shadows are created and also measure the Earth's rotation. They will be needing an open space, chalk, and tape measure. Let me end my presentation with this quote. Start by doing what's necessary, then do what's possible. And suddenly, you are doing the impossible. I know how tough teaching has been in these trying times, but we are still here. We are still doing what's possible. I hope you learned something from me today, and you'll be able to apply the knowledge for the benefit of our pupils. Once again, this is Leia Dizon Policarpio from Bataan Elementary School, Orion District. Thank you.
Thank you, Ma'am Leia. Sigurado ako marami na naman kayong napulot na aral ngayong araw na ito. Hanggang sa muli po nating pagkikita sa mga susunod pang webinars. Inuulit ko po, reminder po, kailangan po nating sumagot sa assessment and evaluation na sa ibibigay po naming link. At heto po ang link.
With Aerosol welcome, the OIC head teacher of Justice Emilio Angeles Gangkayko Memorial High School, Orion, Bataan, a woman behind this team, a very approachable and diligent person, to give us her closing remarks, Ma'am Evelyn C. Kicho. Ma'am.
Salamat dahang moderators na laging nakangiti. A blessed day to everyone, especially to our innovative leader, officer in charge, Schools Division Superintendent, Sir Roland M. Pronda, to Ma'am Milagros Piñaflor, our CID Chief, who always radiate her beauty of servitude in SDO Bataan, and of course, to our EPS in Science, bigatin pero hindi sa size, WW, a man of work, a man of wisdom, may salita, may gawa, ang ating napakasipag na si Sir Edwin Riel Bermilio. Maraming salamat po sa lahat ng opportunities na patuloy niyo pong sinishare para sa ikauunlad ng ating Science Department. And napakalaking bagay po para sa atin ang division webinar na ito. And sabi nga po sa isang quote sa Step to Health, it's not about being better than someone else. It is about being better than you were yesterday. So, mag-aim daw po tayo to have a better self. So, mas maganda daw po yun. And that is very true for us dito sa atin dahil ngayong araw na ito may bago na naman po tayong natutunan at sana kaakibat ng pagkatuto ay yung ating kagustuhan na ibahagi ito sa iba. Lalo na po para sa bata. Cliché as it may sound, lagi po nating iisipin to be always willing to learn and willing to share. So, ang guro daw po ay laging handang matuto at handang tumulong sa iba. And of course, bonus din po to have a grateful heart. So, with that, let me take the chance to say thank you. Mula po sa ating naging chairman ng grade 4, first to third quarter, Ma'am Fe, Ma'am Neri, Ma'am Juliet. So maraming salamat po sa suporta. Sa aking co-chairman, Sir Jerby Lim, napakalaking tulong ang naibahagi mo sa ating team. Sa ating grade 4 facilitators at program management teams, sa ating mga PMTs. Hindi ko na po kayo iisa-isahin. Pero I would say na I'm very proud of you sa inyo pong lahat na nakakatuwa po na through online lang, posible palang makabuo ng mabuting samahan. And also sa aking grade 4 teams, congratulations and good job. And sa ating kaguruan ng grade 4, more power po, and God bless and stay safe po always. So that's all, and thank you.
So before we end, we would like to thank everyone who contributed to the success of our fourth webinar series. Our EPS in Science, Dr. Edwin Riel Bermilio, Ma'am Evelyn Kicho, Sir Jervy Lim, sa ating mga magagaling at magagandang facilitators, Ma'am Miraflor B. Peralta, Ma'am Francia S. Quiro, Ma'am Nancy P. Macaraig, Ma'am Biliorita M. Mercado, Ma'am Rizalyn D. Cruz at Ma'am Leia D. Policarpio.
At syempre, sa ating mga mahuhusay at mga batikang PMTs na talaga naman laging nandyan para handang tumulong sa ating online platform, Ma'am Josephine Dizon and Sir Rabi Mark Gonzalez. Sa ating Google Meet, Ma'am Catherine Bernabe and Ma'am Maria Teresa B. De Jesus. Sa ating program design, Ma'am Renchel Teles, and Sir Gerson Dando. At syempre, sa ating moderators, kay Ma'am Mary Jane Espiritu and yours truly, Ma'am Bernadette de la Cruz, na mag-iiwan ng isang kasabihang nakuha ko lang po sa internet according to Nikos Kasakis, once again. He said, true teachers use themselves as bridges, inviting their students to cross and then joyfully collapse and inspiring them to construct their own. Once again, with that, maraming salamat po. Stay safe, everyone, and God bless us all.
Bye!